All right, so kind of moving along here, and obviously this is going to be the crux problem for this section, and it's really just because of the steps that are required for this problem to be able to get through it. We have a similar concept. We have a radical. We want to eliminate the radical, but unfortunately we have more than just a radical. We have the 6. And so we can't just move the radical to the other side, have one on each side, and move from there. But we still are going to take that same process. So we'll start off and we'll move one of the radicals to the other side. And so obviously I choose this one because when I move it over, I get the positive. I mean, that's the main reason there. So at this point, we start the problem off, and we're sitting here with 4y plus 16 is equal to, it doesn't matter how you put it, but we'll put 6 plus the square root of y minus 5. At this point, you remember our thing that we wanted to do. The thing that we wanted to do was we wanted to square both sides to be able to get rid of the radical. So, our goal was to get rid of the radical. Well, obviously that'll take care of that one because the square and the square root will cancel, and on this side we'll be left with 4y plus 16. Well, in algebra, to keep things balanced, if you do something to one side, you must do the same thing to the other side. So that's where it gets ugly. I'm not going to lie to you. This is the part that makes this thing ugly because this requires a FOIL. So let's bring that off to the side. Let's remind ourselves what that means. So right now we have 6 plus y minus 5 quantity squared, which is actually 6 plus y minus 5, square root of y minus 5, times 6 plus the square root of y minus 5. And so if you start foiling this together, remember, you take your first times your first, that's 36. You take your first times your last, that's plus 6 square roots of y minus 5. You do your inners, so that gives you plus 6 times y minus 5. And you do your last, and remember that in that case there you have the square root times the square roots cancel, and you're just left with y minus 5. I'm going to stick it in parentheses just so you can kind of see where that came from. But just recall that if you take, for example, the square root of 5 times the square root of 5, that's the square root of 25, which is 5. So essentially what happens is, there's more to that property, but the radicals undo each other because when you put them together, you have a quantity squared of what's inside, and so then the radical and the square go away, and we're just left with what's underneath. So we apply that same concept. In this case, we're taking something like an expression times an expression. We're just left with the expression. We combine like terms. So we've got 30, well, let's do it this way. I've got the 36 right here. I've got a minus 5 right here. I put those together, that gives me 31. Plus, I've got a 6y minus 5 and a 6y square roots of y minus 5 for a total of 12 square roots of y minus 5. And then I've used my numbers, so then all I have left to go on the end is my plus y. So I bring that stuff back over and slide it back in its spot. So this is equal to 31 plus 12 square roots of y minus 5 plus y. At this point right here, this is different than anything we've done. We're in some ways back to this problem right here where we had a radical on one side and numbers on the other side, because we can get to that spot. So we're at this spot right now where I can actually move all of my things that aren't under a radical. So like 31's not under a radical, y is not underneath the radical, and technically 12 isn't either, but we'll get to that in just a minute. And I can go ahead and move those guys to the other side. So I can subtract 31. I can subtract y. I can do some housekeeping here real quickly. That gives me 3y minus 15 equals, those cancel, 12 square roots of y minus 5, and those canceled. Now technically at this point I can go ahead and move that 12 over, but that's going to create an issue where I'm going to have a fraction or fractions on this side. But because of its multiplication right here, I can go ahead and square this guy. And whatever I do to one side, I have to do to the other side. So let's address these separately. Let's take the first one out here. So we've got 3y minus 15, quantity squared. That's going to be 3y minus 15 times 3y minus 15. So we start foiling that. That gives us 9y squared minus 45y minus 45y plus 225. I'm assuming that we're getting better at foiling, so I didn't go through and show you all the color and everything as I move my way through. I bring that back up here, and I know that I have 9y squared minus 90y plus 225 equals, now in this case here, I'm going to write out one more step, that square belongs to this 12 and it also belongs to the radical. So I have 12 squared times the square root of y minus 5 squared. So I can distribute that square, and those are properties of exponents that you would come to my class with and already have in your arsenal. We start to simplify this. We're good housekeepers. We bring down what we haven't used. So 9y squared minus 90y plus 225 is equal to 144. 12 squared is 144. The square root and the square cancel each other, and that leaves me with y minus 5. Getting closer, getting closer. I distributed property of that guy right there, so that gives me 144y minus, let me pull out my calculator, 144 times negative 5 is negative 270, or 720, excuse me. I'm a good housekeeper. I bring down what I haven't used yet. 9y squared minus 90y plus 225. So now this is back to where we've been towards the beginning of class. I'm looking at this guy. I see that I have a quadratic. I see the squared right here. And if you have a quadratic, you move everything to one side. So we're going to subtract 144, subtract 144. We're going to add 720, add 720. Be a good housekeeper, keep things neat and organized. So we get 9y squared. 144 plus 90 is minus 234y, and 225 plus 720 is 945. So now we're ready to, well, the first thing is we always look for a greatest common factor. So we do start off and we say, okay, is anything going to go into 234? Remember, our properties are our divisibility rules. With our divisibility rules, we take the digits and add them together. Well, 2 plus 3 is 5, plus 4 is 9. That would work. 9 plus 4 is 13. 13 plus 5 is 18. So it looks like we can take a 3 out of each one of those numbers. So let's go one step further. Let's see if 234 is divisible by 9. It sure is. And let's see if 945 is divisible by 9. It sure is. So we actually can pull out our GCF of 9 out of each one of these guys. So when we pull that out, we get a 9 out in front. Let's make that black, and we get y squared minus, let's pull that calculator up and see what my division was there. Put that on the top. 26y plus 105 is equal to 0. At this point, we're ready to bottoms up. So it's product sum factor. So my product, remember, I take my first number, my leading coefficient, times my last number. So remember, that greatest common factor is out front now. I don't care about anything but what's under that radical right there. That 9 is not a part of me. So my product is going to be 105. My sum is going to be negative 26. I pull out my calculator. I go y equals. I type in my product, 105. I divide it by x. Because that's essentially like saying 105 divided by 1 is 105. 105 divided by 2 is 52.5. 105 divided by 3 is 35. Remember, we're looking for 26. 105 divided by 4 doesn't go in evenly. 105 divided by 5 is 21. Well, if I did negative 5 and negative 21, those add together to give me negative 26, and they multiply to give me 105. So I come down here, I got my 9 still hanging out in front. I take my y minus 5 and my y minus 21. Now at this point, I don't have to do anything because there's no number out in front, right? So since there's not a number right here, a leading coefficient, I don't have to do bottoms up. So I can skip that step, and those are my factors. So let's go back to the original question and see what we were asked. We were asked to solve to see what y's would make this equation true. So when you have radicals, we need to check our answers. So we go one step further here. We take each one of these factors and we set them equal to 0. Alright, this one just goes poof and disappears. This one becomes y equals 5, and this one becomes y equals 21. So we've got two numbers that we need to check to see their validity. So we come back up to the top, and for conversation purposes, I'm going to go ahead and erase this stuff right here so I have room to do my scratch work for this. So give me 1 second here. And obviously you wouldn't erase your work, you would just go to a different spot of your paper. Alright, so now I need to do my check. So when I need to do my check, we had two numbers. We had y is equal to 5 and y is equal to 21. So we start checking those to see if they make the original equation true. So we take the square root of 4 times 5 plus 16 minus the square root of 5 minus 5, and that question is, does that equal 6? Well, if we plug this in our calculator, that's going to be 20 plus 16, that's a square root of 36, minus the square root of 0. The question is that equal to 6? Well, that's 6 minus 0, so sure enough, 6 equals 6, and that's a check. So that is one of our solutions. We go ahead and we check the 21. So we do the same thing. We plug the 21 in. So we get 4 times 21 plus 16, take the square root of that, minus 21 minus 5, square root of that, and the question is, does that equal 6? Alright, so I'm not 100% sure. 4 times 21, just make sure I do it right, it's going to be 84. So 4 times 21 plus 16, so that's the square root of 100 minus the square root of 16, and the question is that 6? Well, the square root of 100 is 10, sorry about that, minus the square root of 16, which is 4, and sure enough, 6 equals 6, check. So in this case here, both of my numbers are my solutions. Both numbers make this original equation true. So like I said, a little bit longer question, requires a little bit more process and steps. So utilize this video as a guide. Work through the problem with the video, copy it down, jot down little notes along the side, then go back and practice it on your own. Obviously there's going to be challenges along the way as far as remembering what comes next, when you can do what, and that's what practice is going to help you with. Don't forget to check. You need to always check whenever you have radicals or whenever you've squared both sides.